There we go. Hi, everybody. We're going to be looking at the Algebra 1 section of IXL, but this is in the geometry part, which is F. We're going to be doing volume. The volume is literally how many boxes can fit inside this of 1 meter cubic boxes. And so one way of thinking about it is to look at the area of the base and multiply by the height, how many stacks of boxes you can have. Since the base of this is 7 meters by 8 meters, the area of the base is 7 times 8, or 56 square meters. That means that you could fit 56 boxes in the bottom of this big cube or in this big rectangular prism. One way to look at it is to think of it like this. Let me see if I can see if I can get it to work here for us. There we go. So I've got this big box, and one way to think of it, and a really good way to visualize it, is to imagine a little box down here. That's 1 cube. And what we're going to do is we're going to fill up this base with boxes. And we know that it is 7 meters across. And this direction, we've got 8 meters. And the area of the base, and that's the way we usually write it, is length times width, or 8 times 7 in this case, which is 56 square meters. And in order to find out how many of these boxes, there's supposed to be 7 of them across here, and there's 8 this way. That means there's 56 boxes in this first level, and we know that there are 4 levels high. 1, 2, 3, 4. And there's 4 meters tall. So the volume is equal to the area of the base times the height. And in this case, we're looking at the area of the base is 56, or length times width. Some people like to look at just length times width times height, but it's better to think of it as the area of the base times the height. In this particular case, we're looking at 56 for the area of the base times the 4, which gives us 224 meters cubed. These are cubic meters. These are these little boxes. And there's 56 in the bottom, and there's 4 stacks of them, which gives us 224 cubic meters. Turn up my volume so you can hear me. Let's see, media. There we go. That's probably better. All right. The next one is the volume of the cylinder. And in this case, it's a little harder to visualize how many of those little cubes can fit in the bottom. But we know that the area of the base is the area of a circle, which is pi r squared. So again, a good way to think of the volume of a right prism, and in this particular case, we're looking at a cylinder. And some people would think of this as a right circular prism. So we're taking the area of the base times the height again, same thing. In this particular case, the area of the base is pi r squared times the height. And in this case, we're looking at a radius of 5 centimeters. Notice that they gave me the diameter instead of the radius. The radius is 5 centimeters. So in this particular case, I've got pi times 5 squared times the height, which is 6 centimeters. And this is 25 times 6, which is 150 pi. Now that's an exact answer, but it says to round your answer to the nearest hundredth. So we have to multiply 150 times pi. If you use 3.14, it may not be accurate enough. So it's a good idea to use your pi key on your calculator. My pi key, let's see, there it is. Pi times 150, and I get 471.238. When I round it, 471.238, And when I round it to the nearest hundredth, that little bar is just where I'm going to round it. I should have actually put it on the bottom. That's going to be 24. So it's going to be, oh, darn it, 471.24. And it is to the nearest hundred. What? Oh, it said to use pi equals 3.14. I was using a more accurate value of pi. All right. So what did they put? Oh, 471. All right, fine. All right, what is the volume? This is going to be the area is, sorry, the volume is the area of the base times the height. Sorry, that's ugly. And we've got 1 cubic yard here. Now, in this particular case, we're looking at a wedge, and we can see that it's half of a cube. But a good way to think of it is that it's a right triangular prism, because the right triangle is the base, and then we're going through a distance. So in this particular case, we're looking at the area of the base, which is 30 times the 6, which is 180. I don't want to spend a lot of time on those, but okay. Now we're supposed to use 3.14 this time. I'll actually do it right. Our radius, notice, is half the diameter. So we're talking about the radius is 7 millimeters. And we've got volume is equal to the area of the base, pi r squared, times the height. In this case, the approximately 3.14 times the radius squared times the height, which is 5. And nice to have my calculator available since I don't want to do it by hand. Uh, 769.3. Notice that I use the approximate there because the 3.14 is not what pi is. It's only an approximation. 769.3. In this case, area of the base is 10 by 1 high, which gives us 10 cubic meters. This is one where you can actually visualize it really nice because you can divide this guy up. Let me see if I can make 5 of these. 1, 2, 3, 4, 5. Hopefully everybody can see the 10 cubic meters that are there. And if it were higher, we would have that many layers of cubes. But you can see the little, hopefully you can see the little cubes here. Sorry, I didn't quite join those together. There we go. Now it's a little nicer. There. Anyway, there's 10 cubic meters there. In this one, I've got 49 times 7, which is 343. Uh, 3 cubed is 27. Just make sure I'm in the right units. Now this time we're looking at a, if you like, it can be thought of as a pyramid. This is a circular pyramid, or some people would call it a cone. I'm looking at the area of the base times the height divided by 3. So the volume of all pyramids, and this is sort of a pyramid, is equal to 1/3 the area of the base times the height. And what's nice is this works in general for all pyramids. In this particular case, it's a circular pyramid, so we're looking at pi r squared times the height. And so we have 1/3 times pi. The radius, again, they gave me the diameter, so the radius is 6 centimeters. This is 6 squared times the height, which is 10. And again, I'm going to use the 3.14. So I've got 3.14 times the 36 times 10 divided by 3, 376.8. And this is in centimeters cubed or cubic centimeters. Some people have heard this called cc's. That's cubic centimeters. What's really interesting is that 1 cubic centimeter, 1 cc, is exactly 1 milliliter of volume. So if you have 1,000 cc's, you're looking at a liter. Makes it easy to make conversions. This one is 376.8. There we go. Area of the base times the height. This is 19 cubed because the volume is equal to the area of the base times the height. Or in this case, 19 times 19 times 19, which is 19 cubed. Don't happen to know that one in my head. Which is 6859. And this is in cubic yards. That's a lot of cubic yards. 6859. 13 cubed this time. So 1373. What? Oh, calculator did it wrong. My fault. I should have been more careful. I was trying to use the Y to the X key, and I ended up using a different one. It looked wrong, and I should have checked it. It's on me. All right. Let's see if I can actually do it right this time. Again, we're looking at the area of the base times the height. This is going to be 66 times 5, which is 330. See if I can actually do one right in my head here. Got to quit relying on my calculator. What is the volume? 11 cubed, that's 121 times 11. The area of the base is 121. This is the volume. And that's going to be 1331, 1331. Area of the base times the height. This time they actually gave me the radius. So we're looking at, but it's 1/3. Remember, this is a circular pyramid, if you like. So the volume is equal to 1/3 the area of the base times the height. And the area of the base is 36 pi. That's pi r squared. And the height is 19. So this is going to be 12 pi times 19. And I'll go ahead and use my calculator. Stupid thing. 12 times 19 times 3.4. 715.92. And that's only an approximation. This is an exact answer. This is an approximation. And it is in cubic millimeters. 7, 15, 20, keep making mistakes. I gotta quit doing that. All right, what is the volume? Area of the base times the height. You can think of the base as being the 19 by 4, but you could also think of it as a 19 by 19. It doesn't really matter. If you happen to know what 19 squared is, 19 squared, what is it? 271, maybe? No. Yeah, I think so. Anyway, no. What is it? 19 times 19. That is 361. And then multiply that by 4, and you'll get your value. I'm just going to write it down. Volume is area of the base times the height. And this time I'm going to use this as the base and that as the height. And of course they're interchangeable. And that is 19 by 4 by 19. And I am going to use my calculator just to make sure. 19 times 19 is 361, yeah, times 4, which is 1444. And it is in cubic inches. Area of the base times the height. But this time they are going to, I should follow the 5 problem-solving steps. In this particular case, I'm going to write the formula, which is the volume is equal to the area of the base, which is pi r squared, times the height. And in this case, okay, they want me to use the 3.14. They gave me the radius, which is 5, so this is 25, that's 5 squared, times the height, and it's equal to the volume. Now I forgot to substitute. I'm going to go ahead and substitute that in parentheses like I'm supposed to. 863.5. So I'm going to go through my 5 problem-solving steps. They are labeled diagram. There it is. Then I have a formula. Then I substitute inside parentheses. I did that. Then I simplify. I take my 3.14 times 25, which is 78.5. 863.5. And then I solve. So I followed all my steps exactly as written. Diagram, formula, substitute, simplify, and then we solve by dividing by 78.5 on both sides. Now some people are going to say, well, I don't have to follow the steps. But the problem with this is that if you don't go through those 5 steps and you do it each time, every single problem is going to be different. And sometimes you'll be able to figure them out, and sometimes you won't. With the 5 steps, you'll be able to do them every time, or at least most of the time, divided by 78.5. So my height was 11 inches. And again, follow the steps. We have a diagram. The formula is the volume is equal to r squared times h, that's the area of the base, times the height, times 1/3, since it's a pyramid. So I have 1/3 times approximately 3.14 times the radius, which is 12 squared, times the height is equal to the volume, 2562.24. Sorry, my writing is kind of getting ugly here. So I'm going to go ahead and multiply this out. 12 times 12 times 3.14 divided by 3. And we're going to take 150.72. H is equal to 2562.24. Okay, so I did my steps. Here they are. Diagram. Formula. Substitute. Simplify. And finally, solve. We divide by 150.72 on both sides. 2562. 50. 17. So height is approximately 17 meters. And we say approximate because that's an approximation. The 3.14 is the approximate. So it's approximately 17 meters. And we're getting there. It's taken a little while. what is the value of G? Well, in this case, we've got the volume is equal to length times width times height. The volume is 112. What is the value of G? I'm going to call that G, the length. G times 2 times 14. 14, I said. And so I'm going to divide by 28 on both sides. And G is equal to 4. Approximately. No, exact. 4. In this case, we're going to divide by 21. I'm going to go ahead and simplify it a little bit. 357 divided by 21, 17. Because we want to get it done today. Sometime today. Okay, in this one, I probably ought to go ahead and write it out. The volume is equal to 1/3 pi r squared times the height. So it's a 1/3 right there. There we go, that's a little better. So we've got 1/3 times pi times 25 times the height is equal to 314. I'm going to go ahead and do the rest on the calculator. So we've got 25 times 3 by 3, and then we've got 314 divided by that. 12. So H is approximately, the height is approximately 12 inches. Sorry this is taking so long. It is my own fault. I missed a couple. The volume of the cone, same deal. Volume is equal to 1/3 pi r squared H. The volume is 565.2. 1/3, approximately 3.4. The radius is 6 squared times the height. So we're looking at 12 times 3.4 and 15. So H is about 15 feet. All right, what is the height? Looks like we have a volume is equal to pi r squared H. In this case, approximately 3.14. The radius is 12. And it's 7234.56, man. A lot of writing there. Okay, so 34 divided by 3. And we've got 48. So 7234.56 divided by 8. I'm going to check this again, 3.14. There it is. 72. Approximately 15.998, so it's about 16 centimeters. Okay, hopefully only a couple more. What is the height of the cone? So it looks like we're taking 3.14 is equal to, since the volume is 1/3 pi r squared. And this is 1/3. Pi is about 3.14. Radius squared, oops, times the height. It's a square, sorry. 3.14 4, the radius is 1, squared is 1 times the height. So it looks like we are getting about 3. The height is about 3 meters. Solved it in my head, makes it easier. All right, what is the value of C? Since C cubed is 125, since volume equals C times C times C, 125 is equal to C cubed, and so C is equal to the cube root of 125, which is 5. Area of the base is 16 times 15, which is 240, I believe. Area of the base is 1/2 base times height. Let me just write this out for you. It's 1/2 base times height. That's the area of that base triangle. And the 15 is my height. So this is 1/2 times 4 times 8, which is 16, times 15, which I believe is 240. Just gonna check it. Getting tired of going backwards here. Volume is 240 cubic millimeters. And maybe one more. What is the radius? Oh, they're gonna make it a little harder, that's good. So the volume is 1/3 pi r squared h. That's supposed to be a third. There we go. Man, that's sad. Okay, there we go. So 1/3, 3.14. The radius squared, we don't know. The height is 12. And the volume is 314. So we've got 4 times 3.4, 12.56. Now, in this particular case, we have a couple of extra steps in order to, I'm going to show you what I did. So I have a diagram that's labeled, I have a formula. This is the formula for a cone or a right circular pyramid. I substituted inside parentheses. I simplified. And now I'm going to solve. I have to divide 314 by 12.56. And I got 25 is equal to r squared. So then I have to take the square root to find the possible radius, and the radius is 5 feet. And we got one more. In this case, we have the volume of this is a triangular prism. That's what this thing is called. See, a triangular prism. The base is that triangle, and I know that the base is 1/2 base times height. That's the area of the base times the height, which is the 18. And there's 2 different heights here. And that's one of the things I don't like about this particular kind of formula, is that they use little h to represent the height of this triangle, which is t right here. And then they use h to represent the height of the prism. What I generally do is I use a capital H for 3-dimensional height, and then I use a little h for 2-dimensional height. So if I'm looking at that triangle that is on the base here, the height of that triangle, I call it little h. And then when I talk about the prism, which if I put it on its side the way it's supposed to be drawn, should really be drawn like this. So, sorry, it's a little off, but this height is the height in 3 dimensions. And so I use a capital H for that height. It just makes it more obvious what's going on. So anyway, the volume is 2246.4. And we want to find the value of t, which is the height of the triangle. So I've got 1/2 the base, which is 15.6. The height is t, and then the capital H, which is my three-dimensional height, is 18. So I've got the height. When I simplify all this, I get 140.4 times t is equal to 2246.4 divided by 140.4. Which is 16. Oh, exact. 16 meters. We're not done yet. All right. What is the volume? So area of the base times the height, pi r squared, and I'll use the capital H this time for the height for 3 dimensions. So we're looking at pi times 2 squared times the height, which is 7.9. And of course, this is a volume, and it's approximate. So we're looking at 4 times 7.9 times 3.4, about 99.22, approximately. One more. What is the value of G? It's the same as the other one, so I'm just going to do it by hand. Volume is equal to 1/2 base times height times the height. It's 1/2. The base is 22. The height is G. The large height, or the height of the prism, is 11.3. So the volume, oops, oh well, I'll erase it. 2933.48 is equal to 11 times 3, 124.3. 2933.48 divided by 23.6. Put a comma. There. And it looks like I might be done. Oh, volume 37 cubed. 50,653. 50,653. And that looks right. And the volume of this triangular pyramid. Okay, this one's a little tricky because we're talking about the volume. I might as well write it out. The volume is equal to 1/3 the area of the base times the height. Now this, of course, is the height of the prism, or in this case, the pyramid. Now, the area of the base is this right triangle that you see on the base here. And the area of the base is 1/2 base times height. They're trying to trick you a little bit, times the capital H. So I'm looking at 1/3 times 1/2. The base of this triangle here is 20, and the height of the triangle is 33, times the height, which is 25.6 of the pyramid. And there's 2 different heights going on there. So it looks like we've got 20 times 33 divided by 6 times 65, 28, 16. Okay, just to reiterate, we're looking at a pyramid, which is different than a prism because it has a 1/3 in it. The area of the base has a 1/2 in it because it's a triangular base instead of being a square or something or a rectangle. That's 1/6 times 660, which is 110 times 25.6. So 2816 cubic centimeters. One more. All right, this is definitely the last one. Volume of this cone is 1/3 pi r squared times the height. And again, I'm going to use capital H for my height of my cone. It's 1/3 times 30.14 times the radius squared times the height, which is 21.2. So I've got 3.14 times 64 times 21.2, 1,420.12. And since it's my last one, I'm going to double check. I'm going to multiply 64 times 3.14. It's the area of my circle, that's my base, times the height, and divide by 3 because it's a cone. Yep. 1420.12. And nearest hundredth. And we're finally done. That one took a long time. Sorry, I missed a couple. Hopefully you guys will have a little better luck than I did. And I will see you next time.